Welcome to the Introduction to Matlab Session 1. 3 parts to this session, starting with a look at what Matlab actually is and what these movies are aiming to do. Secondly, we'll take a simple marine science problem, something very common and easy, and compare what we do in Calculator versus Microsoft Excel and then in Matlab, just so we get a feel for the different levels of programming. And finally, we'll move into Matlab and look at typing in and reading in data from text files. And we'll do some simple plots and some linear regression. So for now, we're in part A. What is Matlab? Well, I'm going to put this in the context of what I teach, which is marine remote sensing. And if I look at the programming skills that my students come in with, I'll class it as IT level and some applications of languages or software at that level, and then the proportion of my students that come in at that level. I'll start at the higher end, so things that just use point and click. And that's things like Google Maps or Word, and in the simple cases, Excel. And about 60% of my students are in this bracket. Next down, things that use point and click, but also have some element of scripting. So that's some very application-specific programs like Fledermaus for hydrographers and ArcGIS for spatial mapping and analysis. And Excel has some programming element in that you can type in formulae. About 30% of my students are in that bracket. Next down, scripting software package users. So this is some kind of programming structure, but with a lot of predefined capabilities and functions, and that's things like Matlab, and similar programs like IDL and R for statistics, Maple for mathematics. And maybe 6% of my students come in at this level. And we'll nudge down to the low-level programming, low to mid-level programming, and that's languages like C and C++, Fortran, heavily used for modeling, and Python and the shell scripts. And possibly as many as 4% of my students come in here, which leaves no students yet at the very low level where they speak zeros and ones. So let's just have a look at a few examples very quickly. Let's take an example of a shell script. We won't dwell too long on this because we'll do more on the actual programming later. Here's the title of the shell script. It always ends in .sh. So in order to use a shell script, you simply go to the command line and type in the name. Here's a definition of which shell I'm using. And here's a for loop that searches for all the files that fit this naming pattern. So the star is a wildcard, just like in Microsoft DOS. Here's the end that says when you get to this point, go back to the beginning of the for loop. And in the middle, there are some manipulations of the file name, creating a new file name. And here we use the very powerful sed function from the bash or the C shell, which is just like using search and replace in Word that you might be familiar with, but if you've got thousands and thousands of lines of input to deal with, this is much more efficient. So that's just one of the things that sed can do. Okay, let's take a look at Matlab. And here's a very short example where I've defined a new function. Here's the name of the function. Here's what values I have to input in order to use the function. So there are 6 inputs. And over on the left here, these are the outputs that will be spat back out for me. And here are the sums that will be done. So that's just a very simple way of expanding the functionality of Matlab. So Matlab has many such functions predefined, and that's what makes it a mid-level scripting software package. So there's a lot of things that it can do for you that are already defined rather than you having to program them yourself. So and then at the very top level, we just note the humble calculator, where every single manipulation you want to do, you have to type in by hand yourself. So one good question to ask is, if most of my students are in this category, why do we want to bother learning Matlab? And I'll just make a quick example here with a voyage down to the Antarctic as Antarctica, and we spent about 2 months travelling up and down in transects onto the shelf. And the red dots here, crosses, all represent places where we stopped and put instruments in the water to collect data. But we also had underway instrumentation, so things that were measuring continually all the way along the track for every day, every hour, every second. And those are the data files that are going to start causing us problems. So let's have a look at an example. And just to stop us from going completely mad, I found one that's already had some averaging. So this is data, it gives us the timestamp, so date and time, latitude and longitude, and in this case a photometer underway. So for example, we would want to plot the latitude and longitude all the way along the track, or we might want to start comparing those values with other instrumentation readouts so that we can pick out where two instruments measured at the same time. So every 10 seconds, one measurement, and this is 1 day of data only. So we're starting on the 14th of January at just past midnight, and we end just before midnight at the end of that day. So text editor was able to open that with no problem, and Excel will open the file in this case. I just need to tell it to delimit with a space. And for some applications I find it useful to separate the time so I can decimalize it, and then we try and read in the data. Okay, so how much is that? It's about 8,000 rows, a little over. So far so good. Let's try and plot those latitude and longitude values. I'll choose a simple XY scatter plot. And this is where we can wait a little bit. And waiting a little bit just for 1 day of data is enough to drive me crazy. So this was my demonstration of why you want to learn Matlab. So the aim of these sessions is to address people in these groups who might find this kind of thing a little bit scary, and to convince them that it is fun and you're able to do so much more and so much quicker when you can use this kind of functionality to analyze and plot your data. And just before we start working in Matlab, let's just open up the program and see what we get. Takes a little bit to initialize, a few seconds. And then it presents us with an array of windows. So in the center is the main one, the command window, where we can type things in, operate on variables. So this is a scalar variable I've just created. I called it x because I felt like it. I could make it a vector instead. So that's a 10-element array. Matlab has a useful function that is remembering your previous history, so it appears here, but it's also accessible to you with the up arrow key. So I can just tab upwards with the arrow key to recall the functions I've used before. And I can plot my data, and I can choose which color and which symbol I'd like to plot it in. And each new plot I create comes up with a nice new figure window, which has some other functionality we'll look at later. There's things like you can change your view angle, you can edit the color map, change the properties of the window. These things you can also do and control from the command line. Up here we have a useful indicator of which directory we're in, so if you want to open a file, at the moment you could open everything that's in the Matlab directory, and currently there's nothing in there. With point and click I can navigate to and fro. And I can also navigate through my file structure using the command line. And that's just using Linux or Unix commands. I can see where I am, so forth. Over on the right is the current workspace, and this is all the variables that are currently loaded in memory that are available to me to operate on. So if it's not here, I can't really use it. And then down here, the command history keeps a record of everything that's done in this session and sometimes previous sessions. So you can choose to clear it, and you could choose to save it for later. And that's one nice way of accessing successful commands. But the other way is to work from a script. So over here you've got a new script function, and that opens in Matlab's own editor. And that's nice because it color codes for you like in programming languages and shows you a different color for a different type of thing. So if I start with a comment is denoted with the percent at the beginning, then Matlab codes that in green. If I type in some kind of command, Matlab codes that in black. And in this way I can save all of my commands in this text script, and it might be that for a particular data set there are quite a few lines of commands that you want to do, and so by saving it as just a simple text file you keep it very, very small and very portable. So all of my old scripts fit onto a little USB stick, and that's really handy. Let's just open up a recent one to give a quick example. So you can see in some cases there's quite a few commands, and if you were to not save this as a script you would probably end up wasting quite a lot of time. So that's Matlab, and now let's try and do some marine science.